Hello students, today in this video we will study about the effects of electric current. In the previous video we studied about what is electric current or generally what is electricity. Now let me continue with the concept of electric current. First let us try to remember what do you mean by electric current. What is electric current? I said to you, electric current is flow of electrons. You know, every conductor consists of atoms, and atoms have positive protons, neutrons and negative electrons, and the nucleus does not play any role, which is having protons and neutrons does not play any role. Only the electrons revolving around, they are going to flow, the outermost electron, right? And electric current is the flow of electrons. And also we studied about electric circuit. Okay, what is a circuit? Circuit is an unbroken path, the path for the electrons to travel, that unbroken path, that you call it as electric circuit. In a case of a electric circuit, we can have simple devices, yes, like for example, I can have a bulb. Okay, I can have a bulb, I can put it a circle here, and I can have a bulb, and I can have a cell. I'm going to have a cell, or I'm going to have a battery, and I can have a switch, right? I can have a switch, and this makes a very simple circuit, a simple circuit. Now, I told you a cell. What is a cell? Electric cell. An electric cell is source of electricity. It is a source of electricity. And I told you again that in a cell there is a terminal called positive terminal, and there is another terminal which is called negative terminal. And electricity flows from positive and again comes back to negative. This is called conventional current. What is this called? Conventional. Old method. Okay. Always it is said that it travels from positive to negative. But you see really electrons flow from negative to positive. You learn more about it later. Right? I got a bulb here, and this is the positive terminal and the negative terminal, and this is called a battery. A battery is a group of cells. When I have more than one cell, two cell, three cell, then it becomes a battery. It gives more energy. If I take for example a cell of 1.5 volt, your ordinary pencil cell, torch cell, you will be seeing that it is written 1.5 volt. Yes, volt also is one of the units, right? And if I have two cells, what will happen? 1.5 plus 1.5, it will become 3 volt. You will have more energy, right? And car battery, it will be something like 12 volt battery. That means it can produce more and more energy. At home, we get electricity. The electricity is around 220 volt to 240 volt. Yes, this is very high voltage. Yes, we can operate a fan, a bulb, all the things. So many appliances we can use. Okay, with this now, I will continue with more idea, the concept of what are the effects of electric current. That is what we are going to study in this chapter. Before that, I will introduce two important concepts. One is called conductors, right? You already know about conductors. You know about metals, you know that. I told you about aluminium, about copper, any metal you can take. Yeah, they all are conductors. What are conductors? Conductors allow electricity to flow through, or conductors allow electrons to flow through, and that is conductors. You can have metals, mainly all metals are good conductors of electricity. But there are the other part of it, they do not conduct electricity. They are bad conductors of electricity, and they are called insulators. Insulators. Insulators does not allow electricity to flow through them. What is an example? You see wood. I cannot allow electricity to flow through them. It is also a solid. It also has got atoms, but this will not allow electricity to flow through. You can say insulators like wood. You can have glass. You have rubber gloves. Okay, rubber gloves. Why people wear rubber gloves? Because it is an insulator. So two categories are there. Some of them are conductors and other part is called insulators. So with this in mind, we will move to the effects of electric current. Okay, what is that effect of electric current? What electricity can do? Yes, you see it is giving light. So from electricity I can get light energy. That is one of the effect of it. Yes, this is a winter season. In winter season what we do? We use room heaters. We use heaters. Yes, and heaters, that means electricity is changed into heat energy. So one of the main effects of electric current is heating effect. So now in this video we will study about heating effects of electric current. So how does it happen? How heat is produced when electricity passes through? Yes, you might have seen, for example, ordinary electric heater at home. Yeah, in olden days you used to get, nowadays also you will find that something like this, like turns of coils will be there and it will come like this, right? And here one point, from here it goes out, from here it goes out. One goes to positive and another comes back to negative. Yeah, always remember one should be positive and another should be negative. This wound up coil, this coil is called element. What is it called? Element. This is used in geyser. For water heater, the geyser uses element. Yes, the heater coil uses element. Even our iron box, we iron our cloth and everything, that also uses element. This is called element. What is element actually? It is also a metal. Okay, but it is a special type of metal. It is not only single metal. It is actually called alloy. What is it called? Alloy. Alloy is a combination of metals, right? See, if I take copper wire, the copper wire will not give heat energy. The connecting wire I am having, this will not give heat energy. If it gives out heat energy, what will happen? It will burn. Yes, it's of no use. But this element is made up of a special material, and that material is called alloy. Now what this alloy is made up of? This particular alloy, it is made up of two elements called nickel plus chromium. Nickel plus chromium. This is called nichrome. Nickel, nic. Okay, Ni. Chrome, C-H-R-O-M, chrome. Nichrome. It is made up of an alloy. And the alloy's name is nichrome. That nichrome, it produces heat energy, right? When electricity passes through, you'll find that it becomes red hot. It becomes red hot and produces heat energy. You get my point? This is one of the effect of electricity. That is, it is going to produce heat energy. Yes, you can think of some examples of it also. Right. Let me now move on further. In olden days, you found that we had incandescent bulb. Okay. I'm going to the next idea. Okay. See, you had a bulb like this. Fine. You had a bulb like this. Yes, let me draw a little more neatly. Yes. These days, what you have is LED. This is LED bulb. But I am talking about olden days bulb. It was like a small jar. Okay. And you had one wire here and you had another wire here. And from this, you found that like this, a small element is being thinked here to support here, right? And from here, you connect it like this, you connect it like this. One is positive and another is negative. This is not LED. It is not LED bulb. Okay. This is called incandescent bulb. Okay. In olden days, we use it. Now also in some places in villages, in remote areas where LED bulbs are not there, still people use incandescent bulb. This bulb can have 40 watts power, it can have 60 watts power, or it can have 100 watts power also, or more than that also. Right. In how you use all these numbers where you will use it in houses, in household you will use. Here what is going to happen? Is this metal made up of nichrome? Is it made up of nichrome? If it is made up of nichrome, it will give you heat energy and it will give you burn in red hot. Okay. But here, if I touch the bulb is evacuated. Inside vacuum, no air is there. When I touch it, it will be very, very, very hot. So, it is producing heat. But is the purpose of the bulb to produce heat? No. It is mainly converts the electrical energy into light energy. It converts it into light energy. And suppose 100% is there, it converts 85% into light energy and 15% will convert it into heat energy. That is why it is hot here. Now, what this element is made up of? This is also called element. And what this element is made up of? It is made up of a material called tungsten. Tungsten. Okay. Tungsten. Okay. It is made up of a metal. It is not an alloy. Whereas nichrome is an alloy. Alloy is a mixture of metal. Nickel plus chromium. Whereas tungsten is a metal. A small piece only is there. You see that small piece, how much light it is producing? Yes, each metal, each alloy has different property, characteristic. For example, I have some characteristics, you have some characteristics, your father has some characteristic, your mother has different characteristic. Each one of us are different. We all are unique. We all are unique. Like 5 fingers are there, you see. Are they all same size? No. Like that, each and every one is unique. And the metals are unique. Elements are unique. Everything is unique. And you are unique and I am unique. Keep that in mind. Okay. Now, I'm going to erase this. Yeah. Here, the electricity is producing light energy. And partially, it is producing heat energy also. Yes. Now from here, I move on to an important thing and a device called fuse. Yes. Don't you hear? Fuse is gone. Fuse is gone. What is that? What is that fuse is gone? Where is it gone? Did you ever think of it? That fuse is nothing but a circuit breaker. A fuse, you will find a big fuse. Yes, like this it will be. Inside metallic material will be there. And between these two, you will be connecting a small piece of thin wire. Right? And these are the terminals. Okay? It goes like this, it goes like this. And you plug in and plug it out. Right? And this is having a base. And on the base, on a wooden thing, the base is fixed and you pull it. And this is made up of a material of porcelain. Okay, porcelain material is used. A white color thing you can see. Now, that is a big one. You find it outside the house, near the electric meter, where the meter reading is taken. Near that, you will see that it is called a fuse. What is the purpose of a fuse? I told you that electricity is coming from the substation, the electric station, substation around 230 volt. And sometime what will happen? More voltage will come. Sometime you will say low voltage, then the light will become dim, right? And sometime more voltage will come. Suddenly more voltage comes, the bulb will get fused. So many things get into trouble. So you have a circuit breaker. It is going to break the circuit. How will it break the circuit? It is made up of a small piece of wire has been connected here. When more current comes, when we say excess current comes, porcelain, maybe check it, porcelain spelling might be with E will be there. Okay. When excess current, 240, 250, 260 suddenly comes, that is excess current. This excess current, when it comes, the wire will get heated. When it gets too much heated, it will just melt. When it melts, what will happen? The circuit will break. The circuit will break. The circuit will become open circuit. When it becomes an open circuit, current cannot go further. Yes, it is already broken, right? And so all the electrical appliances will be safe in your house. Okay, you get my point? And that is the purpose of a fuse. A fuse is a circuit breaker. It excess of current, it just stops the excess of current by it. The wire will get melted. Once it gets melted, then the circuit will break, or we can say the circuit, there is no path for electricity, for electrons to flow, and because of that, you'll find the circuit will open up. Now, what we have to do now? We have to repair it. We have to check it. So, what we do? In the same thing which I am again drawing, yeah, two terminals are there. One terminal like this and one terminal like this. Okay, one will be for positive and another is for negative. Yes, what you do? You call an electrician, or your daddy he himself will find it. They will take a small piece of wire. Yeah, but you cannot put any wire. There is a special wire, and that special wire you take it and again put the screw, connect it and tighten it again, and this again will join the circuit back. And again when you put it back into the base, again electricity will start flowing and current will come. You understand what I am saying? Yes. This fuse is a main fuse, but nowadays they found a different way, and that is called MCB. What is MCB? This is M stands for miniature. It is called miniature circuit breaker. What is it called? Miniature circuit breaker, MCB. What is MCB? You will find that in a small box, there will be a small piece like this, and like small switches will be there, right? And what will happen? They all will be down, let us say, or they'll be all up, let us say, right? Down or up, whatever it is, right? What will happen? Suddenly excess current comes. It is connected to small parts. What will happen? By itself, it will drop down. The switch will come down. The switch will come down. That means naturally, when excess current comes, the circuit will break. The circuit will break. So no current will flow, right? And the appliances will are safe then. Okay? The appliances are safe. If not, what will happen? TV will get spoiled. Or refrigerator will get spoiled. Yes? So the miniature circuit breaker will come down. So after some time, when you go and push it up, again the circuit will be able to continue. It will become closed circuit. A path is there for electrons to flow. I hope you understand this. And this is called MCB, miniature circuit breaker. This is going to be, nowadays we use it, MCB. As technology develops, more and more better things will come. You see, once we had only television, and after television, now you are having mobile, and after mobile, you are having smartphone. Like that, so many things. Science is about all development. Technology is connected to science, right? There will be more and more development, and new things will come. In olden days, you had bulb, and after that, you found CFL came, and tube light, that is, which is fluorescent lamp. Fluorescent bulb or lamp, we say, tube light, okay? So now fluorescent lamp, that is also having more energy it consumes. Fluorescent lamp is very long one. Yes, a tube light is a long one. Okay, now you want to save the place, right? We want to save the place. So what we did, we brought CFL. What is CFL? Compact fluorescent lamp. Compact. So much long. Why should it be? So they turned it, made it like this, and with a different design. Yes, they made it like this, and they connected positive and negative. So this much big, it became compact. This much long, it became compact. Then next advancement came LED bulb, light emitting diode. This is LED bulbs are in place. So development will go on taking place. Technology will go on changing, and we also will go on changing with that. That is why I introduced all this in this video. Now I am going to teach you one of the last concept of the effects of current, that is called magnetic effects of current. Oh, what is magnetic effect? Magnetic effect. We know heating effect. We learnt about now light. Now next we are going to study about magnetic effect. Magnet. Do you know what is a magnet? You have seen in your lab, yes, a small piece like this with the north pole and south pole. Yes, and you used to have another magnet. Okay, when I brought north pole and south pole like this, south pole, north pole, unlike poles, they will attract. Unlike poles, they are not same. South pole and north pole will attract. And north pole and south pole will attract. Suppose if I do one thing, I change this now, right? See, I make the magnet, I am going to now reverse the magnet. Okay, and this is south pole and this is north pole. They are like poles now. They both are like poles. South pole, they will repel each other. Unlike poles, attract each other, and like poles will repel each other. We will learn more about it in magnetism. I am now going to talk about to you only about the magnetic effect of current. Now what is that actually? So when we take a magnet, what will happen? I bring a small pin here. When I bring a pin, the pin will be getting attracted. An iron nail, it will get attracted towards it. Where it will get attracted? Till where? Till the magnetic field is there. Yes, if I go and keep the pin here, it will not attract. Where the magnetic field is there, where it can attract only till there, beyond that it will not attract. Yes, and that is called magnetic field. Now if I bring a compass, with north pole, magnetic north pole and south pole, compass, people use it when they construct house and all. Yeah, at that time also they use to see the direction, where to keep the kitchen, where to keep this, Vastu Shastra. Vastu Shastra. In that also they use magnet. Magnetic compass, where is it used? It shows you the direction, geographic north. Earth also is like a big magnet. Inside Earth also there is a big magnet, right, with the south pole and north pole. So it will show north pole and south pole. Yes, we will learn more about it later. Just I am telling you just the words here. Don't get worried. Next video I will make it for only magnet, right? And then you will understand better. I got a magnetic compass. It shows north pole, south pole. When I change it, it will turn here and there, deflect. Yes. Now what happened? There was a scientist and his name was Ørsted. Ørsted, what he did, he was doing an experiment. He was sitting in a chair and there was a table in front of him. On the table, he has so many equipments, apparatus, and then he had a wire. Yes, a piece of wire like this, and he allowed the current to flow through this. Current was flowing, electrons are flowing. Now there was no magnet here, there is no magnet in this area, and there was a magnetic compass. Magnetic compass shows you north pole and south pole. Okay, but when he allowed the current to flow through this magnetic needle, it just deflected. It started deflecting. He thought, why is it doing like this? Why is it deflecting like this? Where is the magnet? He checked everywhere. There is no magnet. Remember, these are happening in 1800, 1836, 46 and all. In that time, he wondered, how can it happen? Then he thought, okay, there is something in electric current. When he switched it off, no current is flowing. Magnetic compass was showing north and south naturally. But the moment you allow current to flow through, when the current is flowing through, you find that again it is deflecting. Yes, it is deflecting like this. Then he thought, yes, that means whenever electric current is flowing, that electric current is producing magnetic field. Electric current is producing magnetic field, and that is called magnetic effect of current. Magnetic effect of current. Who was the scientist? His name is Ørsted. Ørsted. Christian Ørsted. Ørsted's experiment. What is that? When current flows through a wire, magnetic field is produced around it. When current flows through a wire, magnetic field is produced around it. And that is discovered by Ørsted. Oh, where will we use this? Yes, we use it in electromagnets. And that is the last topic of this video, right? Magnetic effect. I'm going to show you a simple diagram. You can do this at home. Take a nail, take a nail, take a big nail, right? Take a nail like this. Nail is made up of what? Nail is made up of iron, right? Nail is made up of iron. Now what you need? Second, you need a piece of wire. Take a long piece of wire, right? And wind it. Go on making turns. Yes, and this end of it, bring it out. Take the front end like this and then connect it to a cell, right? You take a cell and connect it. Positive is here and negative is here, okay? So connect it one to positive and one to negative. Yes, if you want, you can put a switch here, right? On and off. You can put a switch here, right? This is the switch and this is the cell, and this whole setup is called electromagnet. Electricity, magnet. It becomes magnet because of electricity. Yes, this is an iron nail. It will not attract anything. Now, when you allow electricity, you close the circuit, then current is flowing. Yes, and now when I bring pins, small thin pins, the pins will get attracted. It will get attracted. How can it get attracted? Because the iron nail has become a magnet. The iron nail has become a magnet. Just like a bar magnet with the North Pole and South Pole, this also will have North Pole and South Pole, and it is attracting. Yes, and this S is switch, okay, and it is attracting. Oh, this is not a permanent magnet. It is a temporary magnet. So, the moment I off the switch, what will happen? No current will flow. When no current flows, what will happen? This will lose its magnetism. It will not be a magnet. Then the pins will drop down. Yes. So, electromagnet is not a permanent magnet, temporary magnet. As long as electricity flows, it will retain its magnetism. If not, it will lose its magnetism. Where can I use? Think of it. Crane. You will find that the cranes are used for these purposes. In cranes, electromagnets are used. You will find that crane is there, junkyard, cars are there. You want to lift a car. What do? You lower with the electromagnet, lower the chain, right? And it will get caught here, allow electricity, then that will become electromagnet. It will get jammed, and then you can take it like this and leave it, put it in another place, right? And you can use it in factories where big large containers we want to shift it, or large metal pieces we want to shift it. In such places, the cranes are used. There, the cranes have electromagnet to move things. Okay, so these are the basic things you should learn. And whenever we learn about electricity, you should remember a great scientist, and his name is Michael Faraday. Yes, I will tell you something about Michael Faraday in the next video. With that, let us complete this effects of electric current. We studied about the heating effect, and the light is being produced, and now I have discussed about magnetic effect. In the next video, one more effect, that is chemical effect of electric current, that we will study now. Thank you.